Okay, so for chapter 8-3, we are going to be looking at linear functions. And can anybody tell me what a linear function or a linear equation would look like as a graph? What's linear mean? Lines. Just graphs are going to be straight lines. So on the bottom half of your notes and assignment, if you get a bunch of points that don't line up in a nice straight line, you've done something wrong. So that's kind of a nice thing to kind of keep in the back of your head as a checkpoint for yourself. The other thing is we're familiar with this. We talked about this when we were talking about functions a couple weeks ago. In that, a function is like a machine. You input information or ingredients. Remember our Hershey Kiss Factory kind of analogy. You input data or ingredients. You run it through the machine or the function using PEMDAS, and then at the end it spits out a y, and then those two, that x that you input, the y that's the output, you put those together and they make an ordered pair, and that ordered pair is one of many on the graph. Okay, so especially with linear, how many points are there on a linear graph? How many do you think? Mad dollar to anybody can guess it. If I were to ask you to name how many points are there on a line, Colin? It's infinite. Lines go on and on and on forever and ever and ever. Okay, which means there are infinite number of points on that line. So if you look at the instructions for that first upper half of the notes, and it'll be the same on your assignment, it says find 4 solutions to each equation, write the solutions as ordered pairs. First of all, make sure you pay attention to this. We are going to write our solutions as ordered pairs, and it wants us to find 4. Well, there's an infinite number. We just have to find 4, and they don't even specifically tell us what 4 it has to be. So you can find whatever 4 you want, and I'll show you how to choose which ones to do. Okay. To make this a little bit easier, I won't always provide these, but for your notes and for your assignment today, I've provided some a little bit more guidance. So on the back of your notes, if you'll flip over and notice there's some tables, that's what we're going to use to show our work today. So if you stay on the back, and if you look at table number 1, that's going to coincide with problem number 1 on the front. So for problem number 1 on the front, it's y equals x minus 5. So in the shaded gray area that I have blank, we're going to write the equation we're going to use for number 1, which is y equals x minus 5. And I got that from the front. It's the equation given on number 1 on your notes. Now the instructions were to find 4 solutions. It doesn't tell us specifically where they want us to start or what the solutions, what the x values need to be. So everybody's homework is probably going to be different. You pick any 4 x's you want. It doesn't matter, okay, because there's a bazillion of them. So I'm going to kind of stay low numbers and pick kind of easy numbers. So I'm just going to go with -1, 0, 1, and 2. Okay. And again, if you want to pick different ones, you certainly can. Because whatever you pick as your x or your ingredients, we're going to put that into the equation. We're going to run it through the PEMDAS machine, and it's going to spit out a y, and that's going to give us an ordered pair that's on our graph. So for each one of these, we're going to put y equals, and in this line, we're going to put in place of the x, we're going to put our first chosen x, which was -1. So -1 minus 5. And then the only thing here is addition and subtraction. So that's obviously the only operation to do. So -1 minus 5 is -6. And so our ordered pair is -1, -6. When we input -1, we get the output of -6. And those two, that x and that y together, make up one of the infinite number of ordered pairs that are on the line from this graph. All right, next we're going to go to our next line down, and we're going to input a 0 where there was an x. So y equals 0 minus 5. And 0 minus 5 is -5. And so the ordered pair for that line is 0, -5. When x is 0, y is -5. Now we're going to do it again, and this time we're going to put a 1 in for our x. So 1 minus 5, and 1 minus 5 is -4. So that ordered pair is 1, -4. And then our last line is y equals 2 minus 5. And 2 minus 5 is -3. So that ordered pair would be 2, -3. So these are 4 of the infinite number of possible solutions for the equation y equals x minus 6. And again, I say not everybody's homework's going to look the same because you might pick 4 x's and somebody else might pick a totally different set of x's. And it's okay because all of your points are on the, or will be on the graph, but also somebody else that picked different x's, their points would also be on the graph. So if we were to, and we're not going to do this tomorrow, but if we were to do just one big class graph of x minus 5, and I have everybody come up and put their points on the line, there might be 20 different points from all the x's you picked, but they're all going to still be on that same line. Make sense? All right. So when you're asked to just find 4 solutions, pick 4 random x's, plug them in, get 4 y's, and write them as ordered pairs. Now, I gave you these tables to kind of help focus and funnel your attention to what all needs to be as far as the answer, like how you get the answer and how you present your answer as an ordered pair. I'm not always going to provide you with tables like this. So if you're asked to find 4 solutions, just put together a table similar to this. Okay. All right. For number 2, if you'll notice on the front of your page, number 2 looks a little different. Number 2 says y equals -7. Most linear equations have an x and a y. What's missing from this equation? The x. This is called a special case. Okay. And this special case, in this particular one, it's going to give us a horizontal line. Okay. So if we were to graph this, it would give us a horizontal line. And we're not quite to the graphing stage yet, but I just want to give you a little bit of a visual about what I'm talking about. So if we have an XY coordinate, and let's say that this is y equals -7 right here. Okay, make that a little bit bigger. If I was to graph y equals -7, it's going to be a horizontal line that runs horizontally through -7. So if I randomly, and you don't have to do this on your homework, I just want you to know the mental process behind why this works. If I was to just randomly pick 4 points on this line, right? And then I was to ask you to name those points. So for number 1 here, let's name this point right here. And by name it, I mean, what's the coordinates of it? And we kind of have to guess because we don't have numbers here, but we'll call this -10. So what would be the coordinates of that first point? Let's make it a different color, the green one. What would be the coordinates of the green point? -10, -7, right? -10 on the x-axis down to -7. Now let's make the next one blue. Okay, so what are the coordinates of this one? And let's call this -3. So what would the coordinates of that one be? Bella? -3, -7. Okay, and you should start noticing a pattern here in a second. What if we do, let's do a lime green one. So what if we have, and we want to name that lime green point? What would we call that one? No. 0, -7. Okay, do you notice a pattern with our y's? What is our y every single time? It's always -7. So let's do one more and we'll do this one since we need 4. Okay, and we'll call this, that'd be about what, 8? We'll call it 8. All right, so what would that ordered pair be? Bella? 8, -7. Again, what's the pattern all the way down? The y is always -7, okay? Because every single point, forever and ever, no matter what the x is, the y is going to be -7. So on this special case, you don't need to do this. Okay, put an x through that. When it's a special case, you're not going to pick x's and plug them in because you don't have an x in the equation to plug them in. You just have to remember it's a special case. Y's are always going to be -7, and it doesn't matter what you put for the x. Okay, just pick 4 random ones. Now, I do want to, it's not on the front of your homework, but I do want to, I left you guys a blank spot on the bottom right-hand corner of your homework because I want to talk about the other special case because there's 2. Okay, so this is also a special case, and this is going to be a vertical line. And this would be something like x equals 2. So notice on this one, what's missing? The y, right? All we have is x equals 2. And if we want to know what the graph would look like, this is your x-axis and your y-axis. If this is what we're calling 2 on my graph, because I don't have numbers on it, but that looks like about where x equals 2 would be, then the graph is going to look like this. And it's going to be a vertical up and down graph. And I'm not going to go through the whole process again, but just like on the y one, if I pick a point anywhere along here, right, there's a bazillion of them, what's the x value always going to be? Yeah, it's always going to be 2. So does it matter what I put in for the y? Okay, you've got an infinite number of choices. Just pick 4 at random. It doesn't matter. If you want to pick 1, 2, 3, 4, works for me. And again, I don't need all of this with a special case. So 2 special cases, y equals and x equals. One gives you horizontal, and kind of the little memory trick is if you think y horizon, okay, y horizon, if you look out on the horizon, how's the horizon go, right? It runs side to side. So if it helps you to remember which one goes up and down and which one goes side to side, think y horizon, okay? And y's are always going to give you that horizon line, all right? Now I want to go to, I don't know why it does that sometimes. My stuff just disappears on me. It'll come back. There it is. I want to do number 6. So if you flip to the back and on the number 6 table, we're going to put our equation in the gray area that's there in the middle so that it reminds us what our function or what our machine that we're running each x through. And in this case, for number 6, it is 7x minus y equals 14. You still do it the exact same way. You still randomly pick 4 x's that you want to use. Again, I try to keep them low and I try to keep them easy. And I especially like to use 0 because when you plug a 0 in for x, it just 7 times 0 is 0. So it kind of makes it a little bit nice, but you don't have to. So I'm going to pick -1, 0, 1, and 2. Okay. Now, these are a little bit more time consuming because our equation isn't set up y equals, and we want to know what the y equals. And in our first example, our equation was already set up y equals. So it made it really nice when we solved it, we just had our y. Here, we've got to do a little bit more algebra in order to get our equation set up as y equals. So there's 2 different ways you can do it. I personally think one way is easier. You could leave it just like it is, and you could plug in a -1, a 0, a 1, and a 2. And every single time you're going to have to subtract a number over to the other side, and then you're going to have to divide that negative off the y to get y by itself, okay? And you're going to do that 4 times. And that's a lot of work, a lot of algebra. I think the best way to do this is to let's do the algebra first of getting this equation set equal to y just the way it is, okay? So off down here to the bottom, I'm going to write my equation. And I'm going to show you what I'm talking about. 7x minus y equals 14. That's the equation we're dealing with, right? I really care about what y equals. So my goal here is to get it set equal to y. I want to get y by itself because I want to solve what y equals every time. So if I need to do that, if I subtract 7x and I subtract 7x, and this goes back to basic, we've been doing this since I think chapter 2. Solving for variables. We're going to solve for y here. 7x and minus 7x zero out, leaving us -y equals. And then I'm going to write -7x plus 14. I can't combine them. They're not like terms. I'm just going to leave them both on the right-hand side of the equation. And then I still want y by itself. So I'm going to divide by a -1. And what I do to 1, I do to all 3 terms because that's fair, right? It's kind of like giving your kids candy. If you give one candy, you got to give everybody candy. Negative and a negative cancel out, leaving me y equals a -7 divided by a -1 is positive, so that turns positive, and a +14 turns negative when you divide it by a -1. So now I haven't changed the value of my equation at all. All I've done is used a little bit of algebra to move things around to where now if I use the equation y equals 7x minus 14, it's the same equation, okay? I want to really stress that. I haven't changed the value of my equation, but in doing this work right here, one time, I have now made my equations way easier to work. So I'll show you what I mean. So now we're not going to use this one anymore, okay? We're going to use the one right above it. Y equals 7 times negative 1 minus 14. 7 times negative 1 is negative 7, and negative 7 minus 14 is negative 21. And honestly, putting this in your calculator, it's going to be super simple if you just put it in your calculator. The only thing I will tell you is if you're using one of my cheapy calculators, you're not going to be able to input negative 1. So what you're going to have to do is in your mind, you're going to have to multiply 7 times negative 1, which is negative 7. And then if you need to input in your calculator, if you can't do it in your head, negative 7 minus 14 is going to give you negative 21. Okay. If you have a fancy calculator that you can do negatives, it's fine too. All right. So my ordered pair here is negative 1, negative 21. Now I'm going to run my 0 through it. Y equals 7 times 0 minus 14. Super simple. 7 times 0 is 0. So it's just negative 14. So my ordered pair here is 0, negative 14.
Pardon this interruption. This announcement is for the 8th grade girls basketball team. You are to report to the multi-purpose room. Do not change. Just go to the multi-purpose room first and meet with Mrs. Gray. Thank you.
All right, so in this next one, I'm inputting a 1. So 7 times 1 is 7, and 7 minus 14 is negative 7. So 1, negative 7 is that point. And then y equals 7 times 2 minus 14. Well, 7 times 2 is 14, and 14 minus 14 is 0. So I want to show you, okay, you see how much work went into that as far as this little bit of work right here on the front end to get our equation nice and set up, right? Made for a whole lot less math in the table. And the reason I want to point this out is if you choose to use the original, and I just want to show you, and then you can choose whichever way you want to do it. If we have our original equation of 7x minus y equals 14, and I input a negative 1, to be able to work this out, I'm going to have 7 times negative 1 is negative 7 minus y equals 14. I'm going to have to add 7 to both sides to move it over. That's going to give me negative y equals 21. Then I'm going to have to divide by a negative 1. And divide by a negative 1 to get y equals negative 21. Now notice, I got the same thing, right? When I input a negative 1, I got negative 21. But I had to do all of that math. But here's where the rub is, right? Now to do a 0, I got to do the same thing. So 7 times 0 minus y. And if the other way made perfect sense to you, you don't have to put this in your notes. I just want to show you the difference, and then you can decide which way you want to do it. 7 times 0 is 0, so that leaves me negative y equals 14. I still have to divide off that negative, and I get y equals negative 14. Again, compared to your notes, when we input a 0, we get a negative 14, same answer, right? Now we got to do that again. 7, input a 1, minus y equals 14. 7 times 1 is 7 minus y equals 14. Now I have to subtract 7 from both sides. And when I do that, I get negative y equals 7. And now I have to divide off that negative again. And I get my answer of y equals negative 7. Again, compare. It's the same answer as before, but I just had to do the algebra each time. And then lastly, if I put a 2 in, I've got 7 times 2 minus y equals 14. 7 times 2 is 14 minus y equals 14. I have to subtract 14 both times. And I get negative y equals 0. And then I still have to divide off that negative. And I get y equals 0. Again, same answer as before. But I want to show you and contrast and compare the difference to you. In the first way I did it, I had that one little time of doing all the algebra. And then my table kind of was easy to do, right? Or I cannot do the algebra at the beginning. I can use the original equation, but then this is all of the math that goes into tallying each point. So I personally think it's easier to just do all of the algebra once, get your equation set up equal to y, and then use it in your table. But if you want to use your original equation, then just work it and do the algebra each time to solve for y. Okay? All right. Let's move on from there. Hopefully that didn't confuse you by showing you the two different ways, but since there are two ways, I wanted to make sure I showed you both. All right, now I want to go to the bottom half of your notes. We're going to skip number 5 on your notes just for time's sake. And I want to talk about the bottom half of your notes, which says graph each equation by plotting ordered pairs. Okay, so in order to plot ordered pairs, we have to find them. So we're going to use our tables on the back again. And a couple of things I want to point out. One is we're going to be graphing these. So I'm going to be picking x's again, and you can randomly pick any x you want, but look at your x-axis. Okay, your x-axis goes from -8 to +8. So don't pick x's off of your graph. Okay, so when I say it doesn't matter what x's you pick, it doesn't unless you're trying to graph them. And then could I graph an x of 20 here? It's going to be a point on the graph, but it's going to be way off of my coordinate plane that I have on my paper. Okay, so just be kind of smart about what x's you pick. All right, so we're going to go to the table in your notes, and we are going to write the equation for number 8, which is y equals -6x plus 2. It's already set up y equals, so it's kind of an easy one. I'm going to pick x's, but I'm going to be smart about which ones I pick. So let's pick -1, 0, 1, and 2. And now I'm going to do the work of finding each one of these, finding the y value for each one of these. So for the first one, it's y equals -6 times -1, because that's the first x I picked. And if you need to off to the side, it's okay. -6 times -1 is +6 plus 2 equals 8. So my y value here is 8. And my ordered pair is -1, 8. When I do it again and I get -6 times 0 plus 2, well, this is kind of nice. -6 times 0 is just 0, so it's just 2. So the point 0, 2 is on my graph. Then y equals -6 times 1 plus 2. And again, if it helps you to come out to the side, -6 times 1 is -6. -6 plus 2 is -4. Okay, so do the work out to the side if you need to. 1, -4. And then y equals -6, and then input your 2. And again, if it helps you out to the side, -6 times 2 is -12 plus 2 equals -10. So the y value is -10. So my ordered pair here is 2, -10. All right, now I have 4 points. I'm going to go up to my graph now. Okay. And just to help myself remember what I'm doing here, I'm going to write those points. So that's -1, 8 was the first one. 0, 2 was the next one. 1, -4 was the next one. And 2, -10. Okay, so I'm going to graph each one of these. A couple things to note about your graph is that each line represents 2. So if you need just a 1, right, it's going to be in the middle. So you got to kind of pay attention to that. So this would be a -1. So for the first point, and I'll graph each one of these kind of in a different color to help. So we're going to graph this one first, -1, 8. So we're going to go backwards -1 on the x-axis and up to 8. That's 1 point. Then we're going to graph 0, 2. Well, we go 0 on the x-axis, which doesn't go left or right at all. It just goes up to the 2 on the y. Then we have 1, -4. So we go over 1, which is just half of the spot, and then down -4. So there's that point. And then last we have 210, so we go over 2 and down -10. Now, remember when I said when you're graphing a linear equation, you should have all of your lines lined up on a nice straight line, and we do here. Okay, so when you connect all of these with a nice straight line, arrows on both ends, that is the linear equation, or that is the graph, sorry, that is the graph that goes along with the linear equation -6x + 2. Okay, now I'm not going to spend a whole lot of time on this one because we've already covered this. But y = 7. What's that graph going to look like? What do you guys think? Y horizon. Yep. So it's going to go side to side. And where am I going to put it? I'm going to go this. Now, keep in mind, this is your y-axis, right? So it's going to cross my y-axis at 7, which is right here. Oh, don't like that. Let's do that a little bit different. There we go. Right there. And then it's going to be horizontal line right there. And it says with ordered pairs, so we're kind of doing this backwards, but a y equals, do the graph first, and then if you want to, or not if you want to, then just your last step, go ahead and just give me 3 or 4 points. What's my y value on every single one of these points going to be? 7. And then doesn't matter what x's you pick. Nope. Just pick ones that are on your graph. So -6, -2, 3, and 5. And I just randomly picked 4 x's that were along my line somewhere. Okay. If I wanted to show where those points were, -6, 7 would be right here. -2, 7 would be right here. 3, 7 would be right here. And 5, 7 would be right there. Okay. They're all points on my line. Any point with a y of 7 is going to be on my line. Okay, for your homework, I didn't have time, so we're not going to do number 12, which is a fraction, which means number 12 on your homework, which is also a fraction, is now bonus. If you want to do it, you can choose between piece of candy, a mad dollar, or bonus points in the grade book. Your choice. When you come in on Thursday with it done, I'll give you points for trying number 12, okay? For those of you at home, go ahead after you've taken notes in your binder, push load on Cami and submit it when you're done. Email me if you have any questions.